Let's go to LeetCode 662, maximum width of binary tree. For this question, it give us a binary tree, and let's find the maximum width. For example, this tree, you see the first layer have one node. So the first layer, it has a width just to be 1, and the second layer has has 2 and 3. Actually, let me try to see whether this one is 1 or 0. Let's see whether it is correct or not. Yeah, so the first layer, if there is 1 element, the width is 1. If this is 2 elements, you see there is nothing inside between 2 and 3. So that this layer, the width is 2. And for this layer, there is we can consider this one is it also takes up space. So the width will be 4, right? So so the second example, you see, this is with 1, this is with 2. And for this one, I see there is one space here and another space here. So this one is with 4, right? And for this one, there is this space, and there are 2 here, right? And there are 2 here. So there is 1, 2, 3, 4, 5, 6, 7. So let's say 7. We should notice that the maximum width is not necessarily the last layer in the bottom, right? It may be in the middle. For example, this is the width is 2, but this one width is 1. So apparently, for this question, we are trying to do by the layer. So what we think about is we can do the like a BFS. So so the things that we can have 2 variables. One is left, one is right, and for each layer, we have the left, the minimum of left pointer, and the maximum of the right pointer. So we'll have a max variable trying to for each layer trying to compare the right minus the left plus 1 and this max value, trying to see whether we can update this max. If we can update, we just after we iterate layer by layer, we just return the max. One thing to notice is that for this 3 into this node, right? If we use the left and the right, left is that we can keep the same index with its parent, and the right we can plus 1. The reason we do that is that we'll see this one has width just 2, right? If we with minus 1, this plus 1, even for the left, then the width will be 3. That will not be correct. So what we do is that if we have the left child, we just keep the index with the parent. But if we have right child, we have an index that will be plus 1. So let's begin to write code for this. Apparently, we need firstly set the index, right? Need to have 0. And let's do this if root equals none. We return 0 and max. Because if not now, at least we'll have 1 node, right? So it will be 1. and we have left left index equals equals 0, and right equals 0. We are going to use two queues. One is one queue to store the tree node. And we're going to have another queue, which will store the index. Call index queue. And we are going to run for this route. And we are going to have an index queue for this index, right? While this queue not empty. What we're going to do is that we need to have size. We know we need to have the do it a layer by layer, right? So we need to have a size equals here to the size. For int I equals 0, is smaller than size I plus plus. Okay. We'll get a tree node, right? So node equals q dot per. Also, we need to have int index, right? Because we already have this variable plus index q. Okay, so what's that? If this I equals 0, that means this is our left, right? So left equals to I. And if I equals size minus 1, right? So we'll have right equals to I. No, should be index, right? Because index. And when we get the right, we just have trying to update the max equals max plus max right minus left plus 1, right? So this is every layer, and we're trying to see for this node whether it has left child or right child. If node but left plus not equal to null, put for example, this index is 1, right? So we can put for every child, we can have this one to be 2 multiplied by 1. And this will be 2 multiplied by 1 plus 1. Still keep the same. I think we should have because one node we are going to have two one index, we are going to have two space, right? So we cannot use the index and the index plus 1, right? Otherwise, we will not have enough space for this one. So we can use 2 multiplied by index and 2 multiplied by index plus 1 for the right. 2 multiplied by index for the left. So if it's left does not equal null, we'll have q with the offer node about the left, and index q offer 2 multiplied by index. And I will say if node dot right does not equal to null, we'll have Q offer node dot right and the index Q offer 2 multiplied by index plus 1. Then we just return the max after this, right? Trying to see some other test case. One for each layer. X. Nothing that should be ID, sorry. This is ID because what we get is ID. ID, right? This variable we didn't use. If we don't want to get it confused, we just put this one as 0. Let's take some other examples. The time complexity, because we are going to iterate the whole tree, the time complexity will be O(n), and we use a Q, right? It will be linear. So the worst case is for example, the bottom array lives on the tree. So space also O(n).